Hello interwebs, welcome to Let's Fix Computers. I've got another MacBook Air here today. This one is a mail-in, and it's arrived in an Apple box. Please don't send your Apple boxes, because these boxes are actually quite heavy, and they make return postage more expensive. Anyway, so we've got a charger here as well. So, the fault is not switching on. Tried another charger on it, still no power. Has been repaired before with a faulty screen connector that was replaced, they believe. So, let's hope that that's not the source of the problem. That is a problem. When these break, you got to replace them. If you use chargers like this, you can cause problems down the line because there's a bad connection there. You know, you've got potentially sparking power going into the laptop, which is causing a lot of ripple and nasty, dirty input, and that's going to damage the laptop. So if the charger is knackered, you've got to replace it. And I know it sucks because Apple chargers ain't cheap, but it's got to be done. Right, rest of the laptop looks to be in good condition. I'm going to get one of my chargers. I'm not going to use that one. I'm going to advise the customer replaces it. And let's see what it does. Huh. No green light on the charger. It's stone dead. Okay. I'm just going to quickly plug in another laptop just to make sure that my charger is on. Yeah, charger's fine. No green light on the charger. Okay. Alright, well this will be fun because this one's quite uncommon for me. I don't want to say it's uncommon in the grand scheme of things, but I don't see it very often. So, no green light on the charger immediately tells me that we are missing PP3V42, potentially anyway, because that is required to power that light. The light is powered from the laptop, not from the charger. So immediately we're going to check for that main rail and see what's happening there. Right, so this has clearly had past liquid damage. We've got a lot of tide marks on the underside of the panel. I don't know if those are historical or not, though. When I fix laptops, I always clean up the covers afterwards to reset them, so to speak. But there's a lot of tide marks in here, and yeah, I don't know. I don't know what to make of this. Let's have a closer look. So you can see how we've got these tide marks around everything. It looks like there's been a liquid spill and such like. Let's take a closer look. I'll disconnect the battery. That's unplugged. And let's have a sneaky look down here. So I can see some flux there. Has that been replaced? Display connectors are not easy to do. I feel like anyone who's skilled enough to do display connectors would have cleared up after themselves. No, that's had solder work done on it. Yeah. Yeah, that fella's been replaced before. Yeah, that looks fine to me. Okay. Just weird that someone... Yeah, see, look at that. It's just weird that someone who is able to replace display connectors didn't clean the board. Like, what's going on with that? Yeah, it's a bit horrid. Okay. Right, so let's plug the charger in. And let's take some measurements. So I'm going to put my black probe on a screw hole. Oh, did I have a green light for a moment there? Just might have been a glint. Who knows? Right, so black probe on ground, and I'm going to check down here where not PPBus G3 hot. Well, actually, do we have PPBus G3 hot? No, we don't. Also, it's low. Which might suggest a short circuit. So what about down here? This circuit here is where PP3V42 comes in. I don't think it's where I can't remember if this is where it gets generated, but at any rate, we have power coming in from the battery and from the charger here that is combined for PP3V42. So I'm going to have a quick look there. And yeah, we've got 19 volts. What was that? Bad connection? Yeah, look at that. It's oscillating. So it's coming off. It's, well, sorry, oscillating is a bit of a strong word. It's power cycling. All right. So let's kill the power into the laptop and check for short circuits. So we'll go up to resistance mode, black probe on ground, and let's check for a short circuit at the PP bus G3 hot fuse. That's very high. Let's check the other side of the fuse. Also very high. I'm going to pick a random capacitor in the middle of the board that I know is on there. Yeah. No, loads of resistance. There's no short on that line. All right, what about where I was measuring PP3V42? No, that's also very high. Okay, then. Right, that's not giving me anything straight away. So it doesn't look like we have a short circuit at the input. I'm just going to check the backlight circuit. I've no reason to believe that the backlight is involved in this right now. However, just because I know there's been work over there in the past, I just want to check if there's any short circuits there. No. So I'm measuring at the output diode. And we can check the capacitors as well. There's ground. And there's a lot of resistance on the backlight circuit. Fine, okay. I'm going to disassemble this. Let's take the board out so we can see both sides. It's bizarre. Why would you not clean the board? The amount of effort required to change a display connector. I wonder if they did that in situ. I wonder if whoever did that was just mega lazy. Like, they were half decent with the soldering iron, so they did a display connector, but they were super, super lazy and didn't take the board out of the laptop to actually clean it properly. Maybe that's why it didn't get cleaned. DC inboard is a little bit fuzzy. I'm going to clean stuff as I go, so bits that I can take off and just give a quick alcohol brush to, I shall do so. I'm suspicious about that DC inboard, but we'll cross that bridge when we get there. Ugh, flipping hell. Take the board out. If you're repairing liquid damage, take the board out. Don't look, don't check, don't see if you need to. Take the board out. Okay, well, the good news is we found the problem. And the better news is I can probably just alcohol and toothbrush this and it'll come back. Let's see if I get that lucky. If I do, then I deserve the repair where the previous guy didn't. So, Yabu sucks. There we go. Right, I've cleaned all of that schmutz up, and that's just come straight off. So now I'm going to go over the top of the board, and I'll show you this bit. I should have showed you doing that bit. So we'll clean this up, and we'll just see if it comes good, basically. And honestly, I would wager that this will be enough. Pro tip, wipe thermal paste off with some tissue paper or something like that before you go in with the alcohol, because alcohol in a toothbrush will just put the thermal paste everywhere. It's a mistake I've made a couple of times, and I don't do it anymore because it's a pain in the ass to clear it up properly. Right, poor man's board washing go. Ideally, you want a nice big ultrasonic cleaner for this. However, I have an ultrasonic cleaner, but it's an itty-bitty little baby one, and it's not big enough to put a circuit board in. Although I could probably do half of it and then the other half. I'm very tempted to try that out on this, but it's probably going to look all right after this. Just a dousing in IPA and just a brush down with the toothbrush, and this is probably going to look a billion times better. There we go. There's a few tide marks left behind by the IPA because alcohol doesn't dissolve much. It just kind of loosens it, and then you kind of try to brush it off of the board. So this is not a perfect solution, as you can see, but it does look an awful lot better than it did before. And there's no obvious corrosion anymore. All right. Let's stick some thermal paste on there, and then we'll plug it in and we'll just see if it starts. And we may not even have to get the multimeter back out. Okay, and our survey says... Oh. Okay. Right. Let's grab a different DC inboard just in case. Being the genius I am, I paused the recording for a moment and I forgot to unpause when I came back. So I'll quickly just run you past how far I just got. You'll notice I have jumper wires connected, so spoilers for where we're going with this. So what I did was I plugged the power in and I checked it again, and I found we had AC power coming through here, just like we did before. It was not fluctuating like it did before, but it was not progressing either. So this circuit down here is the PP3V42 power supply. So let me open up the schematic and I can show you what that is and what it does. So here is the board view in Flex Board View, showing you this area. And if we switch over to the schematic view, it is this circuit here. So what we have here is we have the charger voltage coming in here, PP18V5 DC in. So that comes in, it goes through this dual diode package, which on the board is this guy here. And what's going on here is we've got charger voltage coming down here, or we have battery supply via PP bus G3 hot coming through here. So if we're on battery, then the battery voltage comes in. If we're on the charger voltage comes in. And if we have both, then they both come in. But because this is a dual diode package, then one of them cannot power the other. So we cannot have charger power going back into the battery and vice versa. So the dual diode just allows either of them to power this circuit. So now, once this comes through here, we go into this guy here, which is U7090, or on the schematic, U7090. So this is a standard buck regulator, and it takes the power coming in, and then at the output here, we've got a coil, some capacitors, and PP3V42. So what I then checked was we had power coming into this chip, and we measured the 19 volts coming in from the charger. However, there was nothing at the output. So I then checked the resistance and found that we have low resistance, less than an ohm. So I'll just show you that. So at the output of the inductor here, as you can see on the multimeter, we've got more or less 0 ohms. So what I then did was I've now soldered on 2 jumper wires, and we're going to inject power onto this. So I've got 2 jumper wires with a short circuit between them, and we're going to put 1 volt into that at 3 amps, and we're going to see what gets hot. So let's set up. Okay, we're ready with the FLIR and its inability to maintain calibration when I move my hand away. It's very annoying. So let's turn on the power supply and see if we spot anything. Right, 1 volt, 2.6 amps. Okay, that is our actual wire heating up there. Is that getting mega hot? Not super duper. Okay, anything else? That's a big flare up down there, actually. We might actually have to make a better connection. I think we have a very poor connection down there. Could it be that the chip itself is burning up? No. That is purely the connection that's making that heat. I'm going to check the other side of the board. Oh, we can't see a damn thing unless we resolve that. Okay, let's get a better connection. That's no bueno. Power off. How long does that take to dissipate, just out of interest? Yeah, there we go. That's fading away now. Okay. I had a suspicion that connection wasn't very good when I did it, if I'm honest, but usually I get away with it. Let's do better. Try harder, be better. I mean, plot twist, it turns out to actually be those capacitors. I'm going to find another place to hook into PP bus G3, not G3 hot. I'm going to find another place to hook into PP3V42, just in case I'm getting punked here. So where else can I jump in on that? It's not a big rail, so there's not exactly a lot of big capacitors or anything on this. Everything that's on this rail is kind of small and weedy. I tell you what I'm going to do. I'm going to take the inductor off and give myself some more space in there. Then I can get a nice solid connection onto the pad. Let's try that out. What's that done for my resistance? Ah, 0.66. That's good. That's a much better connection. I think we'll actually see what we're looking for this time. Once again, it's flaring up just down there again. Alright, well, it's definitely there. Let's, now we've got a bit more space. What is actually heating up? Again, I've got to get a fancy lens for this. You can see, interestingly, you can see the wire coming in on the screen, and then there's a dark spot, and then there's a flare next to it. Is it just that big cap? It can't be. Yeah, that's not PP3V42. Ow. Oh, you know what? I think it was one of those tiny caps this whole time. I just got burnt. Ow. Yeah, it's the tiny caps. How about that? I'm actually a little bit annoyed about that. Okay, let me tell you what I just saw. I'm 99% certain that it is literally this guy here. And the funny thing about that is, initially, these guys are covered. Have I still got it here where I threw it to one side? Yeah. initially these two dudes are covered with a little bit of goop. Are there any other examples of goop covered thing on this board? Inconveniently, no. But they have what looks like a little bit of hot glue over the top of them. And I removed it, just using the hot air to heat it slightly and then the tweezers to take it off. I removed it to check for corrosion on those capacitors. And I couldn't see anything. And I said, oh, well, it looks like those guys are okay. However, it looks like it was actually wrong and they were shorted. So let's desolder my jumper wire and take those two off the board and see what state they're in. Because I think we've got our culprit now. This would have been a lot easier if I'd been able to inject somewhere else. Let's get a real close look at that and see if it looks damaged. You know, it looked a little bit dark from a distance, but as close as my webcam can focus, that guy looks fine. But let's take them both off the board in that case, and we'll see which one of them, if either of them, are shorted. Because I'm 99% certain it's one of those. Whoops. The one on the left was a little bit brittle, I think. Where did he go? I can replace him, so it doesn't matter if he's gone. It would just be nice to know if that was the failed one. So the guy that I haven't lost... Oh, that's shorted. Okay, so that one is kill. And the one that went ping, I think that is gone forever. That's just teleported into the void. Is our short circuit gone? So let's go to ground and PP3V42. The short circuit is gone. So it was the guy on the right. The guy on the left was probably okay, but he's gone forever, so I'll replace both of them. So these two capacitors are both 10 microfarad capacitors. 10 microfarad, 10 volts. They're 0402, so they're quite small. Now, thankfully, in the nick of time, I've recently acquired some 0608, whichever that size is, which I can probably fit in there. So we're going to put on some slightly bigger boys. But thankfully, I don't need to fit in one of the massive 0806 boys that I normally use. Okay, right, I've got a spare capacitor. It's a little bit big, but thankfully I found the one that went flying, and that one is not shorted. So I can put the correct sized one in the smaller gap, and I can cram in the oversized one in the more open space on the right. So let's just bring up those pads. So let's position some capacitors. You're going in there. You're going on there. And the inductor is going in behind. One of these legs is a little bit tarnished, so I'm going to put him on the lower side where the connection is a bit less critical. Right, let's just flow that whole area and see if it all comes good. Going to go right down to about 40% heat here and work from a distance. Oh, no, even lower. Let's go down to like 10, 20%. Okay, I think we're on. It's rough, but we'll cool the board and we'll check if the connections are good. Okay, so PP3V42 is not shorted on either side. This cap should have ground on that side, which it does. Very low. Nice. That guy should be ground. Good. And now I just need to make sure that these resistors here are okay and are not touching. What are they supposed to be? Oh, those are also capacitors. And they are also going to ground. What are those two fellas? That's 7091 and 7090. And that's a pair over on the input side here. So it doesn't matter if we're touching those because it's all ground. Good, so we have found and resolved a short on PP3V42, which is the first minor rail on a MacBook to turn on. It's needed to power the SMC, which in turn switches everything else on. The SMC on a MacBook can be thought of as the embedded controller would be. So that's what it's doing, and you kind of need it. It manages everything. And let's see if it powers on. So we've no reason to believe it won't power on at this point. So let's grab the charger. We've already got everything there. And pow. Green light, fan spin. Just make sure that stays on. And that's a running logic board. Excellent. Op success. I'm going to give this one last wash down now just to remove these tide marks I've left on it. And we'll be putting a nice clean a nice clean MacBook logic board back into the laptop. There we go. It's not as good a job as a full ultrasonic bath cleaning routine would do, but at least it looks like someone gave a crap this time when reassembling this laptop, unlike the last person who just stuck on that display connector and was just like, yeah, that'll do. Ironically, none of that stuff we found on the bottom was actually causing problems, but I don't know. I think that's kind of missing the point if you ask me. Reassembly time. Right, and there we go, everyone. That is one fixed laptop. As always, my support links are down below. For Patreon, Discord, etc., etc. Thank you very much for watching, and I will see you all next time. Bye for now.